Hello and welcome to this lesson. In this lesson, we're going to be looking at how to convert from order basis to base 10. In our previous lesson, we've looked at how to convert numbers in base 10 to order basis. So let's see the simple process of converting from order basis to base 10. To convert from order basis to base 10, multiply the numbers by the powers of the base, depending on the number's place value. Then sum all the values together. So this is just the simple two-step process of converting from order basis to base 10. Let's look at an example that will help us understand this process better. Example. We are told to convert 734 base 8 to base 10. So in this question, we are required to convert from base 8 to base 10. Okay, so we are going to follow this two-step process to get that done. Solution. Before we go ahead to do that, let's assume that 734 is in base 10. So if you have 734, 4 is in unit, 3 is in tens position, and 7 is in hundred position. That's why we have 734. So for the unit, we have 10 to the power of 0. So it's called unit because 10 to the power of 0 is 1. So 1 is a unit, that's singular value. The next one is 3. 3 is in the tens position, which is 10 to the power of 1. And then 7 is in the hundred position, which is 10 to the power of 2. Remember, 10 to the power of 2 is 10 multiplied by 10, which is 100. 10 to the power of 1 is just 10. So you have 10. And 10 to the power of 0 is 1. So that's why this is unit, tens, 100. Okay, so this means 7, you pick 7 multiplied by 10 to the power of 2 plus 3 multiplied by 10 to the power of 1 plus 4 multiplied by 10 to the power of 0. So I just want to show you the process in base 10. But remember, we are not working on base 10, we are working on base 8. So the only difference between what we have done here and what we are expected to do here is the base here is 8. This means instead of having 10 to the power of 0, we are going to have 8 to the power of 0, 8 to the power of 1, and 8 to the power of 2. So that's why I will say to convert from order basis to base 10, multiply the numbers by the powers of the base depending on the number's place value. So the place values of this number determines the power of 8 that we'll be multiplying with. So let's go ahead to do that. So this will be 734 base 8 is equal to 7 multiplied by 8 to the power of 2 plus 3 multiplied by 8 to the power of 1 plus 4 multiplied by 8 to the power of 0. So as I said earlier, the only difference is instead of having 10 to the power of 2, we are now having 8 to the power of 2. 8 to the power of 1, and 8 to the power of 0, because we are converting from base 8 to base 10. If we were converting from base 4 to base 10, this would be 4 to the power of 2, 4 to the power of 1, and 4 to the power of 0. Okay? Very important to take note of that. Next, let's expand this. 8 squared is 8 multiplied by 8, which is... Next, 8 squared is 8 multiplied by 8, which is 64. So we have 7 multiplied by 64 plus 3 multiplied by 8 to the power of 1 is 8 plus 4 multiplied by 8 to the power of 0 is 1. Okay. Next, we are going to multiply to remove the brackets. So 7 multiplied by 64 is 488. So 488 plus 3 multiplied by 8 is 24 plus 4 multiplied by 1 is 4. So when you add these values together, remember, then sum all the values together. So that's what we want to do. So if you add them together, you're going to have 516 base 10. So now we've converted 734 base 8 to become 516 base 10. So therefore, 734 base 8 is equal to 516 base 10. Very simple. Okay. So next, let's look at a situation where we have a value that has a decimal number. Okay. So this will help us to understand how the process changes a little because the number is behind the decimal point. Let's look at another example. Convert 132.32 base 6 to base 10. To confirm that our equation is correct, we are working with base 6. Therefore, none of the values here should be 6 or above because all the numbers in base 6 should be less than 6. So looking at this, we can see that all the numbers are less than 6. That means we are correct. Okay. So in order to solve this, we are going to also consider the place values of all these numbers. So let's solve. Solution. So let's write this number down. We have 132.32. The unit value has a power of 0. The tens value has a power of 1. The 100 value has a power of 2. But what about the numbers behind the decimal point? The first number behind the decimal point is tenth and has a power of -1. 2 here is hundredth and has a power of -2. So when we are now multiplying with a power of 6, remember, since we are converting from base 6, we are no longer multiplying with 8 as we have here, but we'll be multiplying with 6. So we'll be considering these powers. Okay, so let's do that. So 132.32 base 6 is equal to 1 times 6 to the power of 2 plus 3 times 6 to the power of 1 plus 2 times 6 to the power of 0 plus, now we are going behind the decimal point, 3 times 6 to the power of -1, because we have -1 here, plus 2 times 6 to the power of -2. Okay, so now we can consider the values. So now we can consider the equivalent values of these index numbers. So we have 1 times 6 to the power of 2 is 6 multiplied by 6, which is 36, plus 3 times 6 to the power of 1 is 6, plus 2 times 6 to the power of 0 is 1, because any number raised to the power of 0 is 1, plus 3 times 6 to the power of -1. Using the law of logarithm, any value to the power of negative is the inverse of that value. So if we have a to the power of -1, in order to eliminate this -1, you simply write 1 all over a to the power of 1. So this minus sign means inverse of a value. So to remove this minus sign, we simply write 1 all over that value we have here. So 6 to the power of -1 is equal to 1 all over 6 to the power of 1. Okay, so removing this -1 just means 1 all over. 6 to the power of -2 is equal to 1 all over 6 to the power of 2. Hope that is understood. Okay, so we are going to do that here. So we have 6 to the power of -1 is 1 over 6 to the power of 1. And we know that 6 to the power of 1 is 6, so we have 1 all over 6 plus 2 times 6 to the power of -2 is 1 all over 6 to the power of 2. And we have already found out that 6 to the power of 2 is 36. So we can simply say 1 all over 36. So 1 all over 36. Next, 1 multiplied by 36 will give us 36, plus 3 multiplied by 6 will give us 18, plus 2 multiplied by 1 will give us 2, plus 3 multiplied by 1 all over 6. What is it going to give us? 3 is going to cancel out with 6, so we have 1 all over 2. Let's confirm that. 3 all over 1 times 1 all over 6. 3 here, 1. 3 here, 2. So we have 1 all over 2. So this will give us 1 all over 2 plus 3 times 1 all over 36. 2 times 1 all over 36. This will give us 2 all over 1 times 1 all over 36. 2 here, 1. 2 here, 18. So this will give us 1 all over 18. So we have 1 all over 18. Okay. Now what we are going to do is convert these two values to decimal, so it will be easy for us to add them together. So we'll have 36 plus 18 plus 2. 1 over 2 is the same thing as 0.5, so 0.5. So 1 all over 18 is 0.056. Okay. Next, you are going to add all these values together. When you add them, you're going to have 56.556 base 10. So we have been able to convert this value in base 6 to base 10. So therefore, 132.32 base 6 is equal to 56.556 base 10. Very simple. So I'd like you to solve this simple classwork and leave your answer in the comment section. Okay. Convert 321.2 base 5 to base 10. Okay. So we're expected to convert 321.2 base 5 to base 10. I'd like to see your answer to this question in the comment section. If you enjoyed the video, don't forget to like the video. It helps with the algorithm. It helps to push the video to other viewers. Also share it with your friends and subscribe to this YouTube channel for more maths content. See you in the next video. Bye.